Cool. So last week we were looking into some of the easiest way of doing drum. So the first thing we try is just doing looking into this matrix control thing. But basically, the idea is not so tricky. It's basically, it's a sequencer where you have all these things that you can just query over time. So the idea is that, well, at each time you just query what this column will be, what this column will be, and then you go over time until you get it back. So, get column will get you the first one, but now if you do, two, say one, then you get column, you will get the second column. So 0, 1, 0, 0. So basically the idea is that you just want to keep going on. So this thing can be done with, counter 7. So you have like 0, 1, 2, 3, 4, 5, 6, 7. So max is 0 base mostly. So counter 7 would just count until 7 and turn back to 1, point back to 0. So these things will basically give you like 0 to 7 and back to 0 to 7. So whatever you do here, you can get whatever pattern you want. Then you can see that this basically turn these things into the band message that you want. So now you can basically just, once you have this, grab it turn it into like a MIDI drum machine. So, if you put these corresponding thing to the sound that you want, say, kick, hi-hat, snare, hi-hat, kick, hi-hat, snare, and then open hi-hat, then you basically get these things. So the last one will be kick. So kick what sounds like, do we have sound? We don't have sound. Still not getting sound. I think my MIDI seems crash. Anyway, let's forget about it. So this looks like the sample base drum machine. So one thing you can do with the sample base thing is that basically you want to load a bunch of file. So if you're interested, you can look at the material link, that folder link, where you can click here, drum machine, and click this folder button. There's this like patch drum sounds I found on Reddit. It's like licensable, so you can technically use it. But anyway, these are drum sounds that people record and share online for free. But basically that's the idea. So now, if you get part of like this loop, you can actually load it into buffer tilde loop. So you sort of like do this variable thing. So that's technically just a loop, sort of like read, wave, and whatever file name you have. So these things will basically read this and then store it as loop. So now you can just do this player tilde thing. Two meaning that there's like two channel outs, so left and right. So once you've done that, now you can just play tab, you stop it, or you can pause it, and then but you can also use the same idea as start and stop. But this could also, just giving us some way to interact with this drum machine. So, if you want to grab those, hi-hat, one of the hi-hat sound, kick drum, one of the kick drum, snare sound, snare drum, rim, that's the snare drum rim. So now you basically just play these sounds based on your drum sequencer setup. So one thing you can do is something like this. So, let's try this first, I guess. Get to experience how buffer work. So one thing you can grab is from the folder that I share on the website. This folder, drum machine, November 10th. If you click it, you will find this kick, boom, bat kit. There's a bunch of different sounds. So hi-hat, kick, snare, blah, blah, blah. But basically now you can select, your the sounds you like and create this sequencer. So the thing is matrix control. basically matrixctrl, matrix control. Cool. Let's do this, I guess. Your goal is to go all the way from that sequencer, all the way to generating the sound. Anyway, homework 6 will be due on Friday, so let's work on this first. So what you want to do now is try to, get a sense what this buffer work. This buffer is sort of like variable in processing or other programming language. So now you can sort of store a waveform as a variable so that you can play it with another thing. So play tilde something that's like referring to the waveform that you store in this buffer. And everything else is pretty much the same previously. So all the way from here, all the way to this unpack select things until here is the same idea that we explored last week. Just that last week we were sending, node on events to drum MIDI drums, and somehow my MIDI synthesizer crashed. But that's how you do it. So now instead of playing MIDI sounds, you are playing some samples. And next we will see how you can actually use subtractive things to control the sounds that you want to generate the sounds. You find the files down. Yes. What's the number after the play? Like the two after the red and two. That's stereo output. Oh. So 2 channels. Oh, okay. Yeah. So yeah, it's just not clever enough, I guess. You have to specify that so that it knows how many outlets to put. If you do 5, then there will be 5 outlets. Yeah, but this file is like stereo. So it depends on the output channels. So these sounds should be in the same folder where you have your file. Otherwise, you need to also put the folder, some folder slash that thing. So, here we are sort of like assuming these are single shot recording. So, you just start it and you don't want to close it. That's the sound. Drum sounds mostly fine. But for other sounds, then, potentially you want to do something else. But here we are talking about sequencers, so we are fine. And also you see this message thing. So now we are connecting to the left one. So left one will trigger this. So it will actually, just press this start button. If you put it at the right one, it will make it become bank and it doesn't actually send a bank. It's because the right one is like a code inlet, which set set the content of this message, but it won't trigger it. So you want to put it at the left, and here, it's always starts. You don't want to display that message. So this is sort of, again, like the very interesting way how Max MSP is doing with these messages, controls, because everything could be sort of a display, but also a control that you can pass through. Are you guys enjoying it, Max?
It's confusing, but I like it.
You like it? Okay, cool. Yeah.
Well, it could be fun, like
It can be fun. Yeah, exactly.
until it
works. Before it works, it's chaotic. Yeah. All the time it's like that. And you will hear weird sounds while you are developing. Yeah, but I guess the whole idea of introducing Max MSP, I guess, is sort of like broadening your understanding of computing a bit. Is that, there's also other kinds of paradigm of computing that just sort of like, think about parallel computing. It's sort of like because the idea that signal that just flow through it rather than, it's like line by line. Or, think about JavaScript, that's, event-based, trigger-based. So it doesn't has to always be, like Java, C++, Python, where you just, run the code line by line. There's other, coding paradigm which suit their specific use case. Even that's the case, I mean, under the hood is still C.
Do the WAV files have to be in that?
Yeah,
larger?
yeah. I mean, if you do it at the folder, then you just need to add the folder here. But
Okay.
this will be relative path from where this max patch is.
Okay, so they should be in the same folder.
Yeah, same folder will be much easier.
Okay, yeah, because mine is just saying it can't open the file.
It's in the same folder?
I'm not sure if you could just type them like food on the same folder.
Yep.
I'm sure. I was having the issue earlier where the zip file or the zip was a protected file, so I'm not sure if that's related to it.
So this is no zip, right? I think it's fine. What is this then?
This is what I'm getting to see there.
Okay. I guess the easiest way is just close and bring it, right?
Yes. Maybe that's it.
Yeah. There's always something going on when you start Max. Same. Is it a dash thing? Is it dash or? Oh, it's dash. It's not underscore. It's dash.
Let's see.
Hopefully that's the reason.
Yeah, that's easy.
I think you can do it on the fly, I believe. You don't have to reload it. Or maybe you do, because the buffer thing shouldn't run every time when you rerun it. Yeah, I mean, you have to trigger it. So you can add the button to trigger those buffer to load, or you just reopen it. That's all. The drone sounds are on their website. Oh, yeah. Go to the website, go to this week, and you see that folder icon. There's a patch where you can download. This drum machine. Click it, and you'll get all these sounds. These are the sounds that I select. But these are selected from here. You can actually just pick one of those. There's like so many different variations. And you doesn't have to do that things. The first one as rim, you can do something else. You can do symbol. You can do open hi-hat, whatever. Cool. So you can just download it and just grab whichever you like, from this folder. Grab one hi-hat, grab one kick, and then put it outside of the folder. So the only thing you want to make sure is that this, your max patch and your sounds you select should be in the same folder. Otherwise, you need to add the folder, path into this buffer. You say, sound, specific folder, a specific path directly to that file. You able to get the sound?
And things. I think I have to. There's tracking multiple sounds to this one. So it should be good.
Very good. I think that look right. Yes, it is something. Okay, cool. Yeah. Yeah, that's basically it. If you like, you can also explore the next one is like the synths. This will be much more complex. It's basically building up your synthetic drum sounds yourself. We talk about it like, kick drum, you can basically just do it with like a cycle, but you filter it. So this is like a 50 sine wave, so 50 hertz sine wave. And you can also do hi-hat. This is using like the like subtractive filter. So basically you have a pink noise, and then you want to filter that pink noise. So if I didn't do any filtering, it will be the full pink noise. So pink noise sounds like this. If we just set it here, so this is pink noise. But if you just hmm, if you just make it very short, but at the same time you also um turn this into a high pass. How do I? Oh, okay. High pass into only very high frequency, then you can sort of get some hi-hat-ish sounds. So, you basically just grab this idea and, for snare drum, you want something in the middle and, hi-hat something in the high. And, you can also consider something else. Then you can sort of get some, drum patch you like, give you some 808 kind of. Uh, why is this sound really weird? Okay, cool. So that's the synthetic one. But for now, let's try to make this work. You good? The buffer. But technically, we do have the tempo file, but I guess it's always nice to do it yourself. Try to redo what you saw in the max patch, because oftentimes looking at it is one thing. If you want to build it, there will be additional troubles. Cool. I think one thing we didn't actually look into is when we talk about filter, we didn't actually look into this biquad thing. So that's time to do it. So the reason why we need to unpack is because the things will get columns. So you get the column. So in this case, this is 0. So the first column, it gets 0, 0, 0, 1. So this is 0, 0, 0, 1. So you unpack it into 4 different numbers. Select one. Whenever you get a 1, then you will trigger this band message. This band message, yes. And you will trigger this star so that you play that song. So that's how it works. And that's why you need this unpack thing to unpack these 4 numbers into 4 signal flows. Not signal flow, 4 messages. So at this point, it will be 0, 0, 0, 1. So only the last one will be triggered. The star is just a method. You don't necessarily need the button. It's just visualizing. Yeah. Yeah.
Oh, you come with the wrong one, so this one should be at the right.
Oh,
You can click on that. You click on that thing and then grab the thing. Up.
right.
Or you just leave it.
Yeah.
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 You're good, yeah. And so you can do whatever pattern you like.
Cool. So it's always helpful, if you're wondering what's going on, the right-hand side will give you this, and that's why we want the right-hand side. If you wanna wondering what's going on at the left-hand side, then you can check what's going on at the left-hand side of this thing. But it's nothing because you are using get color. So the thing is when you use a button, they get a specific position output, then you will get something from the left-hand side. So get column will get a vector for this, but the left-hand side will be, say, I want to query, so this metric control isn't always being used in this way. This is when we are using it as sequencer, but you could also query well, I want to know 2, 4 where it is, 2, 4 what it will be. Is it a 1 or 0? So you can do sort of like a matrix query that it will get the output at the left-hand side. Cool. I guess we could move on into looking at the synth drum thing. So I guess one thing that would be helpful is to first try this. The drum one is very easy because basically it's just it's just a envelope on top of 50 hertz sine wave. So it's not fun at all. In this case, I mean, you can make it more fun. You can also use FNCs to do the drum kick sounds. But for hi-hat, I guess it's time to sort of get a sense what filter is doing. So if you want to get this thing is called filter graph here. And this thing is called ATTRUI, but if you don't want to do it this complicated, you could also just send a high pass message to this. And if you want to test out that change, you could have low pass connected as well. And so when you click low pass, you get low pass. When you click high pass, you get high pass. This is just a fancy way to do it. So you will have so many different options to control the things. So in this case, you are trying to see what are the options you have for this particular object. But in this case, we likely just want to do high pass. So the easiest way is just send a high pass message to this thing. Then you will control this filter filter graph. And at the right is just the good old, envelope things. Now we are just very sharp, almost zero attack and then very sharp sound. And what we are doing is just high pass this ping noise. So, if we don't want to get this sound, let's just listen to how we do ping noise. This is ping noise, filter ping noise. And now we do high pass. Not only the high frequency part is kept, at the same time we do low pass, so nothing got filtered. Now you remove the high frequency part. Now this sounds like, I don't know, like train sounds. It's like airplane sounds. So that's the idea. So this filter can do those things, but you could also see the band pass, which is like in a specific part of it. And you can also reshape this Q value. It will reshape how sharp you are getting. But that's not. So let me turn it back. So this is what we have. Oops. We want a high pass, something like this. I don't really like the snare drum here actually, but anyway. So you get the idea. This filter things could just do whatever you like. So this is the idea behind subtractive synth. It's basically you grab the full frequency spectrogram. So, for pink noise, it's just like the full spectrum. Or, you could take whatever spectrum, whatever sounds you like. But now you are just like thinking about what we can do by just adding a filter on top of it. So if we do this, high pass filter, then what you get is something like this. Then you just synthesize this part of sound. So subtractive synth by filtering noise or certain sounds to make it a synthesizer. But also nice to just get a sense how these filter work. Cool. I guess we are almost reaching the final part. So this is just a patch showing you, everything all together, what you can do. So, the idea will be, hi-hat is just the thing we discover here, that scroll here, where basically this is just, low pass filter, high pass filter actually, high pass filter, whatever range you like, very sharp, attack, and very short duration. What it sounds like. The kick drum is just sinusoid function, 50 sent to cycle, so it's like a 50 hertz sinusoid function, and then some envelope to do it. Of course, you can do it with FN synth to make it sound better, but it's gonna work. This is like fine kick drum, very electronic like drum machine like. For the snare, now you can also do it with FN synths or even using like harmonic way. But if we want to make it more precious sounds, then we can just use this bandpass filter to sort of find this frequency range where you can do something like this. It's sort of like a filter noise. So, it's technically not like a snare, something like hitting your desk kind of. So, you can basically create your drum machine without using any MIDI synthetic, using MIDI. So, first thing we see is like MIDI, but you are technically not generating music. I mean, generating sound, you are just using your laptop's, MIDI synthesizer. And, as you see in polyphonic case where, that synthesizer is very good, it will handle everything for you, but that's just not fun. And then we look into, the sample-based one that basically you grab some of the samples and you do it. So it's sort of like, in DAW, where you have different samples, you have loops, and you play it, and then you try to do the sequencer. But in this case, now you combine sort of everything, where you basically try to get all the different sounds, design it yourself, and do the sequencer thing. So this is where, Max MS3 is very interesting, where, now you can create some sounds, even though sometimes it's a headache to create some sounds, but it's also fun to look at how you can, play with the signal and get some sounds that you can listen to. Cool. Well, that took more time than I expect. But I guess I could just show you what we would do next. It's about connecting processing and Max MSP. So that's what we'll do next. So I could just show you some example where, this is where Max, you can do these things, but how can we send it to processing to draw something? So this is just a tiny example to show how you can do it. We can send message using UDP. So UDP is just like the two-way TCP UDP if you've learned about networking, but basically send it to 127.0.0.1. So this is sort of like this computer. So I sent to this computer at this port 8888. Whatever, we will look into it next class. But now, in processing, one thing you need to install is this OSC P5 package. And, this is just the code. As you can see, it's not too tricky. So you listen to this address. You try to listen to the set x /x thing, /x thing. So now here pretend /x. So the x message is sent as the /x things, and the y position will be sent as the /y things. So now in processing, you can actually listen to those things through OSC. OSC is an open sound control message, but it's just simple. It's just like, /x100 and you send it. And that basically meaning that just like, you want to send this information, x equal 100, y equal 200, then you just send a message /x 100 /y 200. And that's essentially what OSC is doing. So now you can actually listen to that message in processing. So, well, what you can do now is then looking at this, then, whatever you are doing in Max, it will send the message to your network, but the network is routed to your laptop. So sometimes you will see, like, if you're doing web programming or web developing, oftentimes you see this thing, localhost column, whatever. So if you've used, Jupyter Notebook, whenever you launch a Jupyter Notebook, it will say, okay, this Jupyter Notebook server is launched. It was at port 8000 at localhost. But this thing actually just turned into 127.0.0.1. But that's basically meaning that this computer. So each computer in your network has an IP address. So if you want to send to a certain address, whatever, 5.5.5.5, you can send it to, I think that's google.com. So you can send it to a certain IP address. But this specific address, 127.0.0.1, meaning that's sending to yourself. So now you are in Max MSP, sending to yourself needs to be a message where it's sending /x, whatever this is, 200-ish, /y, I don't know, 300-ish. And then you send it to processing. That's actually not 200 and 300-ish because this thing by default is 127 and 127. But anyway, send it to processing, and then now processing, you are listening to these events. Once you hear something started with /x, set it to x. You will run the setx function. So, setx will read the data. The data is 200. So now you set x to 200. Set y is when you see this, you are triggered by this event. You hear something starting with /y. Then you run this function. So now you set y equal height minus data. And that's how you send data to Max, to processing. And you can actually do the other way around. So in processing, you do something and then you send OS's message to Max, and then Max, you can render it or, use that information to generate your sounds. And I'm still working on what homework, next homework will be, but likely something simple that connect processing and Max. Should be hopefully much easier than previous homework on Max MSV. Cool. Yeah. So cool. We are pathing through that steep learning curve. Cool. See you on Wednesday.